Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this little 2021 Ford Transit van. Now this van is my personal van, and I've owned it since day one. All of the maintenance has been done on this vehicle on time, on schedule. But you know, over the last 3 years, I've lost 4 miles to the gallon of fuel mileage. Now, I don't know about where you guys are from, but gas is pretty expensive here, and I am losing a lot of money. So I need to figure out where my fuel mileage has gone to on this vehicle. So the first thing I want to do is get a scan tool on this vehicle and get some basic data. So let's go ahead and get that done, guys. Okay guys, I got communication with this vehicle. Let's hop in and go for a test drive and run some tests. Okay, so what I want to do is I want to get some basic data. So right here I can see my vacuum is good at 16.9, 16.2. I'm a mile high, so that vacuum is good. I'm in fuel control. I got Stoich, the no fuel trims at all. I'm going to go to DTCs. I got no DTCs, no permanent DTCs. I want to go to mode 6. We need to pick Ford. What I want to see here is if I have any misfires that have been going on that I don't know about. But I didn't feel any misfires. So right here, there's no data that's logged. No data that's logged right here where I have misfires. So I'm all good. All good there. So now is what I want to do. I want to go over here. I want to check lambda while I'm driving. I should hold a lambda of 1 as I drive this vehicle. So let's go ahead and make sure that as we're driving and we're loading it, that the fuel control actually is keeping it a lambda of 1. That I don't have some kind of a fuel control issue. Okay, so we're holding a lambda of 1, guys. We're doing really well right there. Get in a little bit here. No, we're holding a lambda of 1. So the fuel control system is working. We're in a fuel cut right there. Okay, now I want to run a couple of other tests. So let's run those tests. The test I want to run is a fuel trim test. So I want to go to sharpshooter, and I want to go to long plus short total trim, and I want to load this chart. Now guys, we want to load this dynamically. That means that we just slowly open the throttle and we run it through the entire range of the vehicle to wide open. And we want to just range it dynamically as the engine is running. Good. Okay, now I want to look at that data real quick. Okay guys, there's no trims that are out. These are all really, really close, so there's not a trim issue. So I'm going to close this test. I'm going to open up the volumetric efficiency test.
Cranking battery voltage.
Okay, so now you just open it up and you run first gear. Wide open in first. And what this is doing is it's checking how much air that engine can pump. Okay, so now let's pull over and look at this data real quick. Okay, so we're all in the green. The yellow is actual and the red is theoretical. So the air is flowing correctly on this. We're going to come over here and we're going to do a compare where we compare the VE against the fuel trims, and we can see it's all green because they're matching. There's no problem. I can also come over here to the power where we're testing how much horsepower this can make at this elevation. And we can see that we're all green, so it's making the right. Okay guys, we're right off of our test drive, and what I found is scan tool data is inconclusive for a problem such as we're looking for. So what I want to do is I want to borescope this engine. I know this is a GDI, a gasoline direct injected engine, and they're absolutely horrible for getting carbon on the intake valve, and the intake port and valve area will create a loss of fuel mileage. I know this for a fact. So what I want to do right now is I want to borescope it and see where we're at with this engine. It's got 25,000 miles on it, and all the maintenance has been done on this vehicle, but let's see what that does for you to keep carbon out of the intake. Okay, let's borescope this engine now. Okay, we're in the intake runner. Let's get down in the port and see what's in this port. Okay, this cylinder's definitely carboned up, but that's what I would expect. This has got normal carbon for a GDI with 25,000 miles on it. The problem is this carbon is enough to create turbulence, and that turbulent air as it enters the cylinder won't be mixed properly with the fuel that's being injected out of the injector. And on an SI engine, if you don't have a completely homogeneous mixture, you cannot extract all of the energy from the fuel. So this is definitely carboned up, guys, as we can see, and that's what I would expect. This has only got 25,000 miles on it. No, it's not horrible like a Mini. This is more what I see when I borescope engines with 20, 30,000 miles on it. But this type of carbon, I know, will give me a fuel mileage loss due to not having an homogeneous mixture in the cylinder. And all SI engines have to have a completely homogeneous mixture to extract the energy out of that fuel. So now that I can see that we've got a carboned up induction system, this induction needs to be cleaned. So let's go ahead and clean this induction, and I'm going to set up this borescope so I can record this as I clean it. So we will see this being cleaned live in this engine as it's running. Okay guys, the 3C chemicals are going to need to be kept in a refrigerator before cleaning. If the chemical's cold, it's going to work way better, and we want the best possible results. So we're going to take the three chemicals, chemical A, chemical B, and chemical C. They're good and cold. They're out of a refrigerator. Never freeze these chemicals. Just keep them in a refrigerator. Okay, now that I've got the scan tool up and it's working, I want to find and select catalyst temperature. Now that I've got catalyst temperature, I want to come over to digital, and I want to set up the cat temp on the very top line so it's easy for me to monitor. Okay, now I've got a cat temp of 605 without cleaning. Now I want to make sure that this cat temperature doesn't get over 1650. If it starts to get towards 1650, I've got to shut the engine down and let it cool down, or shut the chemical off. So now we're ready to start cleaning, guys. So let's go get the chemical in the bottle and get it going. Okay, the most important thing with this whole cleaning is to find the right vacuum port. Now this vacuum port right here is right behind the throttle blade, and it's centralized, and when I follow the hose around it goes to the valve cover. So this is a PCV. So if we pull this off, we've got a fitting right here, and that fitting is going to be the right fitting. It's a centralized vacuum port that goes directly behind the throttle plate. So that's where I'm going to put the chemical in on this vehicle. That's a good port. And we never ever put any kind of hose on here. Like if I've got a PCV hose that runs around, I don't feed the chemical into that hose and let it come all the way around. Okay, this nozzle needs to be right on that fitting. So I'm going to take this hose, I'm going to push it onto the nozzle, and then the nozzle is going to go right to that fitting. Now, this nozzle, this atomizer will atomize the chemical, and it'll go into the motor. Okay, so we've got the 3C Vortec connected to the intake. I've got my scan tool started. I want to make sure that the valve here is off. We're going to start by taking chemical A. We'll take the stopper out. And we're going to fill it to the line. But we're going to open the valve and we're going to raise the RPM up to 3,000 to 4,000 RPM. The chemical goes really quick. It only takes about 30 seconds to deliver that chemical. You'll know when the chemical clears because the fuel trims will giving a lot of chemical into that motor. Okay, so we've given A, so now we need to give B to it. Shut the valve. Fill B to the line. Open the valve and raise the RPM to 3,000 to 4,000 RPM. We don't let it idle while we're giving chemical. It needs to be at high idle. And right away we can see we're taking away 35% fuel trim, so we're giving chemical into the motor. You know it because of the trim. Lots of chemical goes into that motor to clean carbon. It has to. You got to really wet the carbon down in order to clean it. Give a couple of quick revs just to clear out any chemical that's remaining in that intake. Now we want to take A and we want to give another application of A. So we're going to fill A to the line. Make sure we shut this valve first. The valve has to be shut. Fill the chemical to the line. Open the valve up and get in and raise the idle to a high idle right away as soon as you can. Okay, each application is only going to take about 30 seconds. So now we want to go back to B and we want to give an application of B. Close the valve first. I'm going to go ahead and fill it to the line. We're going to open the valve up, and once you open the valve up, we need to give it high idle right away. Okay, now that we've given A and B to it, now we need to give it C. Close the valve to start with. Fill C to the line. Now these chemicals are very different and they're removing different parts of the carbon. So you need to use all three chemicals in order to do a proper cleaning. you want to really clean a car, it's going to take 3 chemicals. One chemical will not remove all these modern carbon. Now we're going to open the valve up, raise the RPM up to high idle. Okay, now we've given C. Close the valve. We need another layer of C. We fill C to the line, open the valve up, raise the idle to high idle. So when C's done, we want to clear the intake, so we want to give it a few revs. Then we'll go drive it to clear the rest. Okay, guys. That's it. It's that easy. The cleaning is totally done on this vehicle now. Okay, guys, just because we cleaned the induction system, we're still not done yet. We need to clean the fuel injectors out because the fuel injectors could be carboned and that can give me problems as well. So what we're going to do for the fuel system is we're going to take 505 carbon remover fuel, and this is a very specialized product that has synergy that works in gasoline, and it'll finish cleaning up those injectors. Now what makes this so good is it's delivered over the next 100 miles or 200 miles. We want to put this into at least half a tank of gas to a full tank, and the more gas, the longer this goes across those injectors, and it does a better job of cleaning. This works in gasoline or diesel, guys. A remarkable product. Okay, so now we've treated the fuel, but we're still not done, guys. We've got an oil treatment here to put in. Okay, we're going to take the 505 carbon remover oil, and this is a special product that was blended just for oil. And guys, is what this is going to do is it's going to clean the rings, because we need to clean the rings up. And if I can clean the newer cars, these new cars have low tension piston rings. The piston rings can get carboned up and they get stuck in the piston, mainly the oil ring. And then the scrapers can't uniformly spread that oil, so I get less compression. But the biggest thing I get more blow-by. And the blow-by carries more oil through the PCV into the induction system, and that's what's making this carbon, guys. The main contributing factor in all these GDI engines to get that carbon on the valve is the PCV. The oil is causing that. That's 8 years of research and development. I know what I'm talking about. Okay, so I know this, and this is my own car, guys, and I want to make sure I don't get all that carbon back in my intake. I need to get my rings freed up. And this car has only had Motorcraft oil. Every product that I put into this car is OE spec. All the oil filters, everything I do is from the OE. It's from Ford. They know better than everybody else how to make the products that they want in their engines or in their vehicles. I believe in OE parts, so I use them. But what you're seeing here is an engine that's been properly maintained and driven normally. And look at what I got. I got a bunch of carbon in the intake. And I've got some kind of an injector, probably carbon on those injectors. Now that we got this thing treated, I'm going to need to change the oil once I run this at high idle, or I drive around the block at real light load so I can exercise the cam phasers and clean the cam phasers. Then I need to drop this oil out before we go further with our testing. So let me go ahead and high idle this. Actually, I'm going to drive this around the block at really, really light load. I want to exercise my cam phaser. I want to get that phaser clean. So let's go ahead and do that. Okay, wow guys, is that incredible or what? With 15 minutes of an induction cleaning, I got 4 miles to the gallon back. Much less to say how much money I'm going to save from all that fuel. Think about my air quality footprint that I'm making. Quality from me driving this car has just gotten significantly better because I clean the intake. 15 minutes of my time and I clean the intake. And this isn't just this car, guys. And since I developed this chemistry that will actually remove the intake carbon, I have seen this over and over. This week alone, I've cleaned 3 cars, and every one of them has gotten at least 5 miles to the gallon increase. One of the vehicles, a little Chevy that one of my employees owns, I cleaned it, guys. I got 10 miles to the gallon better, much less the car ran with significant power increases and shifts better. This is just an incredible invention, guys. Ever since I've made this chemical that can actually remove real-world carbon from an induction system, I've seen nothing but really great results. More power and mileage increases from engines once they've been cleaned. And it doesn't have to be a GDI engine. Port-injected cars, I cleaned another one of my employees' cars with 100,000 miles on a little Ford Explorer, and he got 5 miles to the gallon increase and increased his mileage and his shifting quality. Okay, guys, is that just cool or what? We can actually clean these type of vehicles without removing the intake manifold. It's just amazing. So we saw that we can clean an engine with 25,000 miles on it that's really not that dirty, okay? But even though that carbon, it doesn't have huge accumulations, it was causing enough turbulent activity to where you don't mix the fuel and air properly, so the flame can't propagate as fast as it can when it's a completely homogeneous mixture. So I lost 4 miles to the gallon on this car. Well, what about a car that's got over 100,000 and it's really dirty and it's really carbon? What can we do? Okay, guys, what I want to show you now are some cars that I've recently cleaned that are very carbon, heavily carbon with high mileage. Let's take a look at these vehicles.
ATS Chemical.
These are normal results that I expect from cleaning an intake now. You guys clean intakes with a good product, and you too will have good success in your service base.